Computer, share screen, and we are live. Okay. So today I'm just gonna spend all this time talking about the auto router. Okay. Um, some things we discussed about the auto router is always do your grounds last because normally, and this isn't always the case, but normally you'll have a ground pad and you you will be able to make much better connections to your ground pad than the auto router will. If you put the ground pad uh, in there before you go to the auto router, that works too, but there are some circuit designs that may require more intricate ground track placement, and which I would recommend not doing through the auto router. Um, The auto router is a lot like KiCad in that I can actually take this into the auto router and I can edit it as well. Um, really quick, I can edit like the tracks and the zones and stuff. I can add that in the auto router. I prefer to do everything in KiCad, so I would go back and forth. You can also make specific connections, but I wanted to leave this auto routed actually just so you guys could see this is what it comes up with. And some connections aren't even connected, you see. So like it took this, it took the 3.3 volt connection, went all the way through the chip here, really close to ground and data lines here to make this connection. And now it has no idea how to make this ground connection. The algorithm didn't understand. I mean, it could have just came out here and put a via in the ground plane, but it didn't account for that in the algorithm. So there's a lot of bad connections it can make. I'm not seeing a whole lot more. Some of these vias might not be preferable. You might want to keep it on like a single layer or a certain layer. But let's go ahead. I'm going to strip all those connections really quick. So edit, global deletions, tracks and vias, and they're gone. All right. So do you guys have the whole layout for your boards and everything? Sure. To do the zone, you're gonna go to the right here, add a filled zone. You're gonna click on that, and then you can just pick, you can even do the corner of the actual board. It doesn't really matter. There's gonna be a certain clearance for the edge of the board and the copper, so it will automatically control like where the copper is placed. But you're gonna click on like the top left corner of your board. Might want to change your grid size so that you line up with your I forget which one I used. I think it was this one. As close to this corner as you can. And then when you click, you should get this pop-up window. Do you have that? Okay. So we're gonna create a copper plane on the back side. So select back copper, and then these are all the nets. So these are all the things you have to, or that you have on your board to make connections. We're gonna select the ground connection. This is gonna serve as our ground plane. We can change some of these parameters too for like clearance, minimum width, thermal relief gaps, thermal spoke width. We're gonna want the thermal reliefs. Actually, no, yeah, we're gonna want the thermal reliefs because for the components that are through hole, you're really gonna want the thermal reliefs to make it easier to solder pins. I haven't decided it. I might just make JLC PCB. I might just pay the difference to have them solder it on. Because we'll have the name tags to solder by hand and learn to do, which is simpler. But for the dev kits, I might just have the company do it. But the thermal reliefs will really help them and whoever's soldering those on, it'll make their lives easier. essentially what it is when you stick the soldering iron on there, if it was a solid like layer of copper and a solid connection, the heat from your soldering iron is going to dissipate throughout the whole copper pad, and it's going to make it really friggin' difficult to melt that solder onto the connection. So the thermal reliefs are a method of reducing the amount of copper that's connected to that larger ground plane, so that the heat will be more focused into that pad that you're trying to solder, and so you can melt the solder properly and get a good connection. So this is all okay. The default settings. Just make sure you have thermal reliefs. You can pick whatever display you want. So I have the hatched pattern, and then click OK, and then you're going to be able to now select the corners of the zone. So I just selected the 4 corners of my PCB. You can go to each corner and click. You will left click there. And then the last one, just come back to where you started and click there. And then it should create the zone. Let me know if you see that when you finish. You need help or? Go back. Now. Go to objects and see if maybe you had one of the eyes. Click out of it. Click on the hatch pattern. We just made. By making it like small. You don't have to recreate. So click on the down arrow. Zoom in. Oh, is that the edge or is that okay? Or select things. Uh, click on the edge. Click out the zone. Zoom in. On the UFC. Really tiny. Yeah. Or if we shove it in here. I want that. Yeah, that's the most what I bought. Because for like, cause like if your cord isn't technically connected at all four corners, something wrong with it, then it, um, your- kind of like, it's like, this was your fault. This. There. Sorry about that. Somebody was having an issue. Read that. So that shouldn't have been okay. That shouldn't have been an issue. I think what was the problem is you had some type of clearance setting that it was such a large clearance that the entire board just had no copper because the clearance from everything would have been no copper on the back of the board. So in inches, this is what I have by default, 0.02, 0.01, 0.02, 0.02. This is in inches, not millimeters or mils. Okay. So that should fix everything. And then you should see on all your ground connections on the through hole components, these are the thermal vias I was talking about here. And then because of the minimum clearance, there's no ground in between the vias, so we can't put a thermal relief on that fourth corner. And then same thing for pins in between, they only get the two sides, which is okay. So all your ground pads will have thermal vias as well. Not as important. Well, it is important still for pads, but we're gonna have the manufacturer do it, so we'll be okay. So the reason I wanted to do that first is because I wanted to show you guys that because we have this since we have that ground plane, I can now place vias directly to ground, and I don't actually need to make any of these ground connections. So I can control click on the ground. That will highlight all the ground areas, and I can go and I will route every single ground myself. Now, I don't know if I talked about this at all, but absolutely do not put vias on your pads when you're making your connections. That is a huge no-go. You cannot do that. However, if you have an earth pad, and some footprints will actually already have this implemented. Now, I think there is a ESP32 that has the vias, but if it doesn't, you can actually add them in manually. But the only exception to that rule is adding vias to earth pads. That is okay, and it's for helping keeping the chip cool when it gets really hot. So it just gives it more area to dissipate the heat into the ground pad or to other larger copper sections on the board. It can help you when you're dissipating heat. So one shortcut too, once you place a via on the earth pad, is you can go to special tools, you can go to create an array. And I kind of already did this, but I want a 3x3 array vertically and horizontally with a spacing of 0.05 inches. Click OK, and it will make all those vias for me. And now I can place that as symmetrical as I can. And that connects the front and the back to the ground plane here. So you would click on here, add freestanding via. When you place it, it should recognize that it's a ground. Yeah. So it recognizes, hey, this is a ground connection via. You can right click this via then, click on special tools, and then click on create array. Or to skip all that, you can select the via and just click Control T. Then this will pop up. And I want you can pick a circular array or a grid, like a square, rectangular array. And I want 3 horizontal, 3 vertical. So a 3x3 array of vias. And then I can select the spacing I want in between all of those vias. And you can add some extra stuff, but this is fine. And then I don't want them to stagger at all. I think that they'll kind of zigzag. Let's see what happens if I do that. Yeah, it'll offset them if you want that as well. But I do not want that, so I'm gonna go to create array. I'm gonna have a stagger of 1, meaning they're all lined up, and that will create the 3x3 array of vias. And then you just need to select that top left corner. So hold shift, select that top left via, and then click M, and I can now move the whole grid that I just created. And it just makes your life easier instead of setting 9 vias and then trying to align every single one of those vias so that they're lined up and nice and everything. So I'm gonna undo that because I already have them here. But this is what I recommend doing before going to the auto router. Route your grounds, um, route all of your, or you can either do the ground first, or you can go ahead and do the ground last. Either one's okay. So I'm just gonna go through each one here. All these front components, I'm just making a via directly to the back side. What's up? Um, where? Oh, yeah, I was showing a previous student how to do another. It's just another ground zone on the top. You don't need it. I was showing how to create a ground zone as well. You can do it if you'd like, but that's all it is. It's another ground zone, but this one's on the front, not on the back. You can tell by the red color on the zone here. It's on the front, and it'll match the color scheme of all the other components. In case you missed it, in order to see like all the ground, ooh, I did not want to do that. In order to see all the ground connections, you can hold control and click on ground and it'll highlight all those. And so I'm just gonna go through all the ground connections and I'm gonna pop a via in right there, there, there. And these vias can be beneath chips and stuff. That is completely okay. There, you, okay. Um, you should all be connected. This one. Okay, and I think I have all those now. Okay. I can even turn the rat's nest off so that only the grounds are highlighted. If the zone is making it kind of hard to see, you can go to objects, and this is what I was checking with you earlier. But I can click on the eye right here and make the zone go away so it's a little bit easier to see everything and make sure I have everything connected properly. Like that. I am actually going to add a front ground copper. You know what? I'm actually going to take this front copper zone, this red one, and I'm going to I'm going to move it because we actually do need one over here. I'm going to make it a little smaller though. Sorry, I know I just said you didn't need it, but I'm going to go ahead and move it over here, and it's just going to make uh, this ground connection easier because I can add that front copper there. And then I can do a via. Special tools, create array, 2 by 2. That look nice, and then fill. There we go. So now that ground connection is properly made. We don't have to worry about that. And I think that's all the ground connections. I don't like this. So these thermal reliefs aren't quite making the connection I want to make. Let's go ahead and mess around with that. So I'm going to change the minimum width here. I see the problem. Okay. It's a clearance problem. So I'm going to change, I'm actually going to make this clearance really small. Oh, that's not a good idea. That's a little better. I'm gonna do 0.01 inches for the clearance and 0.01 inches for the minimum width. That will give these thermal reliefs a better connection while keeping a decent distance from the 3.3 volts. And then the only other thing I want to route really quick are these data lines. So these have to connect here. So D plus and D minus, of course, be. In fact, I'm gonna run both of these on the back layer. Okay. This one. Okay. There we go. Why is it doing that? Okay. So I want my data lines nice and close. I want them on the back layer because I can now refill the back copper. And look at that. All this ground copper is going to be a nice shielding for your data lines. Okay. So that's going to help for your signal integrity. I don't think this will be doing anything that you would have to worry about that. We still need to connect this data line here. So this is a less important connection because if we look at the schematic, there we go, here. So the data line has to also connect to the diode, but that's going to be going to ground. So this is just for to protect your board from electrostatic discharge. It helps prevent current from going anywhere it shouldn't be going and ruining any chips. So your signals are going to be going this way and connect to the CP2102 here. That's going to allow you to take whatever program on your computer, convert that to a UART. No, I'm sorry. That's it. It's going to allow you to program the ESP32. So I can hook up a USB and micro B USB to my laptop. I can write a program in Arduino, C++, whatever I want, and you'll be able to program the ESP32 to do whatever the program tells it to do. But the signal is going to be traversing on this USB D minus line, not on the diode. Okay, so the trace for the connection from the diode to the ground is less important than the trace that's going to make this connection to the CP2102. That's the point I'm trying to get across. Okay. So I'm actually gonna let the auto router do those. And I think we're ready. Okay, so this is our board. So we got the data lines, we got the grounds connected. I'm even gonna let it do the 3.3 volts because I'm feeling a little risky. All right. So go ahead and save. And what you're gonna do is you're gonna click on File, click on Export, and then you're gonna click on Spectra DSN file. It's gonna ask you where do you want that. I'm gonna go ahead and throw it in whatever project directory you have. So projects, I have IEEE ESP32 dev kit, and I'm gonna save it right here inside that folder. Go ahead and save. Yes, I'm gonna replace that. All right. So then you're gonna open up that free router software that I told you guys to install. And you should get this pop-up. Did you not install it, or is there issues? Oh, okay. Okay. You can still auto route it just to see like how it works and stuff if you want to mess around with it a bit. But then whatever work you did when you strip all the tracks, it'll remove the vias too. So you would have to redo the vias. So I understand if you don't want to do it. All right. So once you have the free router open, you click on Select Design File. You're gonna go to where you saved that DSN file, and go ahead and select that file, and then click Open, and this should pop up. Should look just like this. All right, it's going to say, please confirm importing stored rules. Beware that rules important from the host system may be overwritten, okay? You want to import your stored rules. So all the rules I have from KiCad, yes, I want to import them into FreeRouter. Okay, make this a little bit bigger. So the color coding is different in this FreeRouter, but this is our design, and these are the connections we still have to make. There's a lot of things you can do with this. So I'm just going to show you the auto routing aspect, but you guys are completely open to messing around with this and seeing what else it can do. But you can see all the ground connections are already made, so it's not going to do anything with that. I can select individual connections, and I can be like, oh, okay, I want you to figure out how the hell to do this. So click on that, click on auto route, boom, done. It connected it from here to there. What about this connection? Boom, done. This one too, done. Went through the whole board and already did it. And you can get a little trigger happy with this, right? You can go through every single one of these and you can click auto route. Even better, instead of that, there is a undo. You can't control Z, so you have to click the undos here. So I'm gonna undo all those. If you don't click anything, you just click auto router. Let me zoom out a little bit. Right here, if I just click auto router, it'll just go through the whole thing and just start auto routing the entire board. Okay, besides the connections that we've already made. So it can make your life easier and it can also make your life worse. So I highly recommend after auto routing, if you plan on using that as a finished design, look over the board before you send the order, because there's going to be some really sketchy things, and I'll try and find some in a minute here. Right. So you can see on the bottom here, after I click the auto router, it's going through batch optimization. And you can click the left button to make it stop at any time. And then to resume, you would just click the auto router again. Right now it's on the 7th pass and now it's done. So what it's going to do is it's going to try and make all the connections just by directly connecting them. And then it's going to find if it can optimize the path that it chose, if there's any better way it could have taken. Mainly the algorithm, I believe, is just trying to reduce the length of track and the amount of vias on your board. So that's what it's going to use to decide whether it optimized your connections. Okay. I say that with quotation marks, optimized. Okay. Now remember, we have 4 layers. So this is going to be on 4 different layers. Once you're done with this, you click on File and Export Spectra Session File. And then click Yes. And then we're going to go back to KiCad, okay? So when you export that Spectra file, it automatically saves the Spectra session over what we had in the File Explorer. So I'm now going to go to File. I'm going to go to Import. I'm going to import a Spectra session. And I'm going to select that one we just did. Click Open, and there's all our connections. Okay. So let's take a look. First thing you can do, just to see if anything's bad, open up the design rule checker and click Run DRC. And we have a few problems here and some ugly tracks here. So, warning, track has a, we have to reroute the ground. Okay. So all the tracks are here. Let's click B again. So that'll redo the grounds. And then let's run the ERC again and see what we got. All right, same problem. So, okay. So track has unconnected end. Is it this one? If you click on the arrows, you can see which violation it's referring to. Sometimes it can be a serious pain trying to select the arrow. Can I right click? There we go. I think I got it. Yeah. So, yeah. So, okay. So it looks like this is connected, right? But if I take it out and then go back in, you want it to lock on there. And that should fix that. There you go. No, it didn't. What's it talking about then? Track has unconnected end. Oh. I wonder. Oh, that's not it. I thought maybe we split the ground plane, but that's not it. Well, that fixed the error with the V bus, the clearance between the VIA and the V bus. Go copper. Under the green? I don't think so. Hold on. Let me delete it. And let's see what connection. I can, yeah. But it's saying that it has a unconnected and oh, there we go. Okay. So there's a extra track in the middle here that has no connection. So if I delete that, go back to my error, run DRC, and it's gone. There we go. All right. So that's pretty common actually. So here's another one right here. Delete. And that should take care of that. My battery's running low. Yeah, serious pain. You have no idea how long it took me to learn that one. Those tracks being stuck under the bed. Okay, we're charging. So here's another unconnected end. So if I click on where I think the track is within the pad, it'll show you there's two overlapping tracks. And then don't click the pad because then it's going to highlight it. If you click here, it'll show you which track you're selecting. So here's one, here's the second one that has no connection. Delete that. And that should fix all the warnings. And then you just need to go through all the errors. So clearances. So the RXD needs a larger clearance from this ground via. So we're just going to move it a bit further. This ground via, a little bit more clearance. I think it's all vias. So all the vias need a little bit more clearance. Here. Yeah. Mm-hmm. And I don't know like how many of the rules like so a new thing in KiCad was the you could go to the board settings here and you can set these constraints. So I don't know if these constraints are passed down. I'm wondering if maybe only these net classes are passed down to the auto router. But I still had those, so I don't know. Move this way over. This one? Oh, that's not it's part of the footprint. Yep. The wonderful confusion over time as all the layers are overlapping each other and you gotta figure out what's what. Yep. Okay, let's go ahead and see if we fixed everything. We got most of them. So hole clearance violation. Where? Right here. That's easy enough. Go ahead and move that. And do keep in mind if you do put your vias over your silk screen, then your silk screen obviously won't be there because you're drilling a hole through the silk screen and now it's gone. So be careful with that. All right, we have some missing connections. Righto. That's easy enough. Just connect it there. Not sure how I feel about this RTS signal. um, so there's so yeah, so that's some of the things you just need to look out for. And I'm not gonna, try and fix everything right now in the moment. One thing you do, oh, I don't even think I added a ground here. So this is just missing. And so, yeah, I can add that track and then it's touching the zone. And so we're okay. And now that makes the ground connection that's needed. You do need to be careful. let me turn off all these. Okay, so I want you guys to see something really important. Okay, here's our ground plane, right? As you have your routes, you're gonna have some ground sections that look a little sketchy. Okay, there's some thin parts. This is gonna be the thinnest part, so this is gonna act like a bottleneck. This is gonna be like your resistance right here. But the main thing I want you to see here is this almost looks like an antenna, doesn't it? Right? This little section right here kind of looks like an antenna. So if you have something that's really noisy close to this, this is going to act like an antenna and you're going to pick up noise on your board. Okay. So you really don't want this. And even worse, if you can avoid it, let me turn all the layers back on. Hold on. So I can reroute this if I were to put. That's not what I wanted. Say this. I'm going to extend this. Okay. This is even worse. Okay. So if I turn the layers back off, now I have a separated ground. So this ground isn't even connected to the rest of the ground. So I have to take this ground and connect it to that ground, which seems okay, but you really don't want to segment out all your grounds. Okay. This is a no-go. You want to try and keep it a solid single ground. There are very, very niche applications where you should have a ground for all your digital connections and a ground for all your analog connections. But those are very rare. 9 times out of 10, it'll make it worse because signals that you may not have made the connection about in your circuit design originally we're using the whole ground in order to reduce EMI, but now that you slash the grounds in half, one's digital, one's analog, well, now some of those signals aren't getting the same ground connection, so they have to take an entire different path, and it's going to pick up more noise and whatever new path. It's just not good, not recommended. It's a very niche thing, very uncommon thing that you would have to do to create an analog and a digital ground. Okay. The most common things you're going to do is you're going to create a ground plane and you're going to create a power plane or even a power pour because you really don't want your tracks burning up and going into flames. Okay. So I'm going to undo what I just did. There we go. All right. And that's basically it though. So here's our dev kit. It's completed. It's routed. It's not the best, but for this application, should work perfectly fine. I'm gonna go ahead and I'm not sure how much of this I walked you. I don't know if I walked you through this process, but here's the JLC PCB plugin. I think I'm not gonna be able. We have 8 minutes. I know, but I don't know if I showed you guys how to download it.
What the JSLD?
Yeah, the plugin. I showed that to you guys in a previous video.
Yeah.
Okay. All right. Well, then you guys should have this if you download it. It's okay if you don't. You can use a different manufacturer and you can use KiCad's thing. But this is convenient because I can pick parts directly that are available from LCSC.
Okay.
So that's what I'm gonna do, and you guys don't have to do this, so don't worry about it. But yeah, bounty. I don't know how to pronounce it, but I'm basically gonna go through. I'm gonna pick all these components out, create a bill of materials, ship it to JLC PCB. They're gonna be like, all right, we'll make your boards. We'll throw these components on with the BOM that I gave them, and you'll have a dev kit. So I'm gonna make about 10 of these. We got about $300 approved. for our order. So I'll make 10 dev kits and I'll make about 50 name tags, I think. I don't know if we're gonna buy components for all 50 name tags, but they're dirt cheap, so I'm just gonna order 50 and we'll have that for whoever. That's pretty much it. Uh, that's everything I have to give to you guys about PCB design. Um, let me go ahead and talk a little bit about next semester. So some things I plan on doing next semester is there's another developer kit called the STM32. It's basically a knockoff of the Arduino Nano. Or one of the Arduino boards. I don't know if it's the Nano. I think it is that one, but I'm not entirely sure. But it's a knockoff of one of the Arduino boards, so it'll do everything that Arduino board does. And then we're gonna make name tags for little business card name tags next semester. So that's what I have planned for next semester. I'll get these printed out this semester, and I'll let you guys know through the Discord. When I have those boards when they've been shipped, and then I'll hand them out to you guys, and you guys can finally have what we created. So, all right, all right. You guys have any questions? Thoughts? Yeah, I know. It came up so fast, really quick. Right. So for you guys online, I'm gonna go ahead and conclude this session. This is our finalized developer kit. And go ahead and you can view it all its glory. This is what the dev kit will look like. Nice and organized. I even actually I don't know if you guys got this. I had you guys add the extra capacitor here in the enable pin, right?
Yeah.
Okay, cool. So that was a problem with the actual dev kit that we found on the forums just because it was related to my senior design. So I added it, and it had to do with the auto boot functionality in the ESP32. So that capacitor should help with that auto boot functionality. So I thought I'd add that because it might make your life easier sometime. But for you guys online, I'm gonna conclude this session. I'm gonna go ahead and stop recording, and I hope you guys got a lot out of it. So I hope to see you guys next semester. I'll go ahead and stop the recording. Go ahead and pay attention to our Discord, okay? I'll post when we have the boards available on Discord. All right. Have a great week.